I wanted to record this video really as a source of reference. I've been playing recently with a Smith's temperature gauge and the voltage regulator that comes with it, and the problem that I was having is I wasn't getting anything like the voltage from the regulator output that I should have been. So after some considerable prising of the case, and it was difficult to get that open, inside the case I found these small components, all surface mounted components. There is, from the input pin this side where 12 volts is connected, a 470 ohm resistor. That threw me a bit because it's actually marked 470, and the internet tells me that the final number should be the power of 10 to the power to which 10 is raised, which then multiplies the first two numbers. So 470 should be 47 times 10 to the power 0. Well, 10 to the power 0 is 1, so it should be 47 ohms, but it's not, it's 470. Taking it out and checking the resistance with a standard multimeter proved that. This is a 6 amp transistor. I think it's an FTZ853, and then this little chap over here is a surface mount Zener diode, and that's got a Zener voltage, a breakdown voltage of 10 volts. So when that starts breaking down to earth, and these are the strips that carry voltage away to earth, the transistor works as a current amplifier and allows a larger current to flow between the input and the output. So those pins are here, 12 volts in, 10 volts out, and I've just measured some of the current as I've connected up through, having repaired this circuit, and I got about 15 milliamps at room temperature, and as I dipped it in a hot cup, dipped the temperature gauge or the sensor in a hot cup of tea, I got it up to about 73 milliamps. So shows a range of current draw to be expected. When I suspected the circuit was duff, I was getting a current draw of about 0.7 of an amp, which was quite concerning because the dyno start that I've got fitted to the engine that this will eventually bolt to only charges at 8 amps, so I didn't really want to be losing nearly an amp just to my temperature meter. So the little transistor, which was what I found to be at fault in the end, was an eBay purchase at about £2.40, which is a lot cheaper than a new one of these Smith's regulators, which come in at about £10.